So this is e to the power 1.1025, and this is e to the power of minus 0.3025. You need to solve this and you'll get it as 0.4069. So the other two will be exercise for the Google Classroom. I'll put it, and it's compulsory. Otherwise, there'll be marks cut from the internal assessment, right? Okay. So this is normal distribution table. Wantonly, I have put this normal distribution table so that for the next problems it will be helpful. So module 1, chapter 4, question number 7, right? We have the random variable z is normalized Gaussian. Find the probability corresponding to this, right? So again, the probability of this is equal to fz 0.595 minus fz minus 2.335. So we need to find this, and we need to find this from the Gaussian, normalized, so to say, tables. Okay. Now straight away we can't find this. So to find the value of fz of 0.595, okay, we need to go to the normalized Gaussian distribution table. So directly this value is not available. What is available to us is 0.59 and 0.60. So against 0.59, so you can see that this is 0.5 and you have here 0.59. So this is 0.7224, right? This is 0.7224, right? That's the value there, right? 0.7224 is the value there. Then for 0.60, the value is, similarly, we can try to find out that 60 is 0.7257, right? This value. Okay. So once we know this 0.59, for 0.59 it is this, and 0.60 it is this. What is the value for 0.595 is what we need to find out. Okay, for 0.595, it's a question mark. So this is a interpolation problem. Okay, I might have put directly some method there in the earlier video, but now I have elaborated it. So now, if figuratively you can write it as a interpolation problem. So this is a straight line. It might not be looking like a perfect straight line, so you need to bear with me. So for z1 equal to 0.59, fz z1 is the value 0.7224. For z2 equal to 0.60, the value of z2 is 0.7257. So for z equal to 0.595, how much is the value for fz 0.595 is the question which arises in the mind, right? So you need to find this. So to find this, the interpolation formula from our numerical interpolation, which you might have used in the, I don't know, first year or second year, wherever it is, maths, is like this. fzz is equal to fzz1, that is this value, into z minus z1, that is z minus z1, divided by z2 minus z1, that is this, multiplied by f of z2 minus f of z1, this minus this. Okay. So this is the formula which is have to be put. So I have substituted here 0.7224 plus this value z minus z1 is 0.595 minus 0.59 divided by 0.6 minus 0.59 multiplied by this quantity minus this quantity, and that turns out to be 0.72405. Okay. Also, we need to find the fz of minus 2.335 from here, right? So that value is 1 minus fz 2.335. This negative values are not available in our Gaussian table. Here only positive values are there. Negative values are not available. So to get the negative value, we need to write it in this form, 1 minus fz 2.335. For 2.335, what are the values which we need to find? So going back to the table over here, 2.3 is given here, 2.34 is given here, 2.335 is not given. So it should be somewhere between these two values. It should be somewhere between these two values. Okay. So, and the method there is, found in the same way. Again, I am putting here the graphical representation. For 2.33, it is 0.9901. For 2.34, it is 0.9904. For 2.335, it should be what? How much? Okay. So for that, the formula is again same formula, 0.9901 plus, 2.34 minus 2.335, or 2.335 minus 2.33, either way, whatever. You can write here 2.335 minus 2.33 also. I think this might be a mistake. This is not the right one. You can write 2.335 minus 2.33. Even if you write this, there's no harm, but ideally that is the right one. 2.34 minus 2.33 multiplied by this minus this. So you'll get the value as 0.99025, right? So you just substitute there and you'll get the value which is 0.7143. So what we have solved is question number 7, right? 5 and 6 default become the Google Classroom, assignment. You need to submit it. Okay. Fine. So now let us go to question number 10. Question number 10, right? Using normalized Gaussian distribution, if FZC is equal to 0.5844, find C. Again, this is for normalized Gaussian distribution. So what is given is FZ, and what is asked is need to find the value of Z equal to C. What is asked is to find the value of Z equal to C. So in the Gaussian distribution table inside, okay, we need to find where this is. 0.5844 is not available to us. So what is available? That is in which values it is between. This value comes between which values is what we need to find out. Okay, 0.5844. Let us go for 0.5844. See here, 0.58, yes. It is somewhere here between these two. This is 0.5832 and this is 0.5874. So 0.5844 is between this two, right? So corresponding to this, you have 0.21. Corresponding to this, you have 0.22. So naturally, it should be, the value of C should be somewhere between 0.21 and 0.22. 0.21 and 0.22. How much? That is what we need to find again by interpolation. So for 0.21, the value is 0.5832. For 0.22, the value is 0.5871, right? 0.21, the value is 5832. For 0.22, the value is 0.5871. So what is the value of Z equal to C when we have 0.5844 is the question, right? So this is again the graphical representation of the interpolation which I have described over here, and again use the same formula over there. 0.21 plus 0.5844 minus 0.5832 divided by 0.5871 minus 0.5832 multiplied by 0.22 minus 0.21 equal to this. So formula is this: Z equal to C is equal to Z1. Z1 is 0.21 plus F2 FZC minus FZ Z1 divided by FZ Z2 minus FZ Z1. So this is FZC or FZZ, whatever you call it. This is FZ Z1, and here we need to have Z2 minus Z1. So all that you should substitute over here. You'll get the value of C, which is equal to 0.2131. 0.2131 is the value which you'll get here. I hope things are clear. Okay. So if things are clear, so now this is question number 10. So naturally 8 and 9 become the exercise by default for the Google Classroom assignment. Okay, you need to solve that and submit, and I am going to put it today itself onto the Google Classroom assignment with a what you call so to say deadline. So solve this and keep it ready, all of you, and tell your friends also who are not attending the class today. Only 14 are there here. If they don't submit, then marks will be cut from the internal assessment and assignment together. That will be the case. Okay, please remember that. So I'll stop the